Hello students, in this video we will see finite difference methods. So here we will see how to find or how to predict next number in the sequence or missing number from the sequence. So we'll see how we can use this difference between consecutive terms to find missing number or next number from given sequence of numbers. So we will solve this example. We have to predict next number in the sequence, this question mark. So at the end of this video we will solve this example and we will solve one more example. Here we will find missing number in this sequence. Alright, so at the end of this video you will be able to solve these two examples. So let us start with some easy examples. Suppose we have this sequence of numbers and we have to predict next number. Now as you can see, all the numbers here are same, 2 2 2 2. So we have to predict this number, and it is not that difficult. The answer is obvious. If all these numbers, all these 5 numbers are same, 6 numbers must be same, right? So in this case answer is 2. So this is pretty simple example. Okay, and the function that fits this given data is this y is equal to 2. Okay, so here we will consider y as a function of x. So for any value of x, y will be 2. All right, let us have one more example. Is 3 5 7 9 11. Okay, you have to predict next number. Now this is also easy example. You can see here all these numbers are even. Okay, and the difference between each number is, you can see, 2 2 2, right? So if all these differences are 2, right? Look at this: 3 plus 2 5, 5 plus 2 7, 7 plus 2 9, 9 plus 2 11. That means here also difference between this number, unknown number, and 11 has to be 2. All right, and the next number must be 13. So you can see here how this difference between consecutive terms helps us to find the next number in the sequence. Okay, and we can easily see the function which fits given data is this: y is equal to 2x plus 1, where x will take values from x will take natural numbers. Okay, x will take natural values. You can find when x is equal to 1 2 3 4 5 6, you have to find 6 number, right? So when x is equal to 6, it will be y will be 12 plus 1 13. All right, so you can see here for this given data we got constant polynomial which fits given data. Okay, because the difference between every term is 0. Now look at here, for this data we got first degree polynomial which fits given data. All right, because the first difference is 2 2 2 and second difference will be 0. If you consider second difference here, that means distance between these two now will be 0, these two 0, right? Like this, let us take one more example. So then we will see one pattern here. All right, so the third example is, suppose you have these numbers 1, okay, 4 9 16 25 36, and you have to predict next number. Now here also you can see all these numbers are squares, right? This is 1 square, 2 square, 3 square. So you can guess next number. But before that, let us use this method that we have used for the previous example. What we are going to do here, we'll consider difference between consecutive numbers. So it will be 3, right? 4 minus 1 is 3. Then here between 9 and 4, 5. Then here it is 9 and 16 and 9, 7. Then 9, then 11. Now look at here. we know these differences. If we know difference between this question mark, that missing number, and 36, then we can find this missing number, right? So if you know this question mark, we can find this number. But how to find this number here, the missing number here? Once we know this number, we can easily find the number here. But how to find this number? Okay, to find this number, you can use this second example. Look at here. What we did here, so we considered difference between these two numbers. Again, apply same method. So here we will get 2 2 2 2, right? That means here the number has to be in place of these 3 question marks. If you know this number, we can find the number which is below 11, which will help us to find number which is here. So what should be the number here? Look at these numbers. All numbers are 2. That means this number in place of 3 question mark has to be 2. If this number is 2, this number has to be 13. So that 13 minus 11 will be 2. And if it is 13, this number has to be 49, right? Because 49 minus 36 will be 13. And the polynomial which fits given data is this x square. So see here when all numbers are constant, same, we got constant polynomial. Okay, when first difference becomes constant, we got first degree polynomial. When second difference becomes constant, we get second degree polynomial. So in general, when rth distance is constant, we get rth degree polynomial which fits given data. Alright, so these are some simple examples. Let's go to some complicated examples now. So suppose we have these numbers 2, 8, 15, 29, 56, and you have to guess this number. Now you can see it is not that easy, right? We don't have any pattern here. We have 2 here, then 8, 15. There is no such pattern we can find, okay, just by observation. So what we can do, let's look at the differences. Okay, if you are able to find any pattern in differences, that will help us to get this number here. What are the differences here? This 6, 7, 14, 27. All right, so can you find any pattern here so that it will help us to find this number here, this question mark? So I don't think so. I'm not getting any pattern here, right? 6, then 7, then 14, then 27. So let us go for second difference. So the second difference is 1, right? 7 minus 6, 1. 14 minus 7, 7. 27 minus 14, 13. Okay, now can you find any pattern here? Not yet, right? Alright, so let us go for third difference. Okay, now look at here. 6, 6. Now there is a pattern, right? Both numbers are constant. 6, 6. Constant in the sense same. They are same. 6, 6. That means the number in place of 3 question marks here. If you know this number, see, it will help us to get this number, which will help us to get this number, and which finally useful to find this missing number. So what should be the number here? Okay, we have two numbers which are 6, 6. That means third number has to be 6, right? This is the pattern there. If this is 6, this number has to be 13 plus 6, which is 19. So that 19 minus 13 will give us 6. Now this is 19, so this number has to be 27 plus 19, which is 46. Alright, and if it is 46, the missing number is 102. Alright, so see, even for this data, okay, where we don't have any pattern here, but we got pattern at third difference. Okay, third difference we got same number 6, 6. And by using that, we got this number, this missing number, which is 102. Okay, and what is the pattern here? What should be the polynomial which fits given data, as the third difference is constant? Alright, so there must be a third degree polynomial which fits given data, right? So at least we can predict, okay, if it is not it may be difficult to find the polynomial, which polynomial, but at least we can say there should be a polynomial of degree 3, right? And you can see here the polynomial which fits given data is this: y is equal to x cube minus 11 by 2x square plus 31 by 2x minus 9. How to find this polynomial, that we will see later on, but you can check for this given numbers. Okay, you can put x is equal to 1, it will give you 2. When you put x is equal to 2 in this polynomial, it should give you 8. Likewise, when you put x is equal to 6, this should give you 102. So this is the polynomial which fits given data. Okay, so this is what is extrapolation is. This is called as extrapolation. We know this data 1 to 56 and we are finding next number. Okay, a number which is outside this data. This is called as extrapolation. Now let's go back to our original example. Okay, our original example was this: 2, 8, 15, 29, 37, and we have to find this missing number here. Okay, this question mark. So let's use this method that we have seen right now. So right now there is no pattern, so let's go for differences between these numbers. So which are 7, 6, 7, 14, 8. And this is question mark, okay, because we don't know what is this number. Alright. Let us get, as there is no pattern here, let's go for next difference, which is 1, 7 minus 6. Still there is no pattern. Go for next numbers. Yeah. Again there is no pattern at all, right? Go for next number. We got minus 19. We have to guess next this number. Now see, as there is only one number here now, minus 19. What should be this number? Okay, the best possible number which fits here is, as this is minus 19, this also has to be minus 19. Alright, then if this is minus 19, this number will be minus 32, this is minus 38, this is minus 30, and therefore the missing number is 7. Okay, so this is how we can solve this example. So we got this missing number, it is 7 here. And what is the polynomial which fits given data? So that has to be 4th degree polynomial, right? Because we got 4th difference as constant. So there must exist 4th degree polynomial, alright? And which is this. It is not so good polynomial, right? We have so many fraction number here. But you can verify this. This polynomial fits given data. When you put x is equal to 1 here, it will give you y is equal to 2. When you put x is equal to 2, it will give you y as 8. When you put x is equal to 3, it will give you y as 15. Likewise, when you put x is equal to 6, this must give you 7. So this is how, by using differences between consecutive terms, we can predict next number in the sequence. This is how differences between the consecutive terms help us. Now let's go to some different type of examples. Here we will find missing number from the sequence. So suppose we have this sequence 1, 2, 3, question mark and 5. So can you find this missing number here? It's very simple, right? Okay, it is 4, right? Because there is a pattern 1, 2, 3. This has to be 4, 5, 6. Okay, and what is the function which fits given data? Y is equal to x. See here, what will happen when you look at the differences between the terms? We get 1, 1, 1, right? So first difference is constant, therefore there is this 1 degree polynomial, which is y is equal to x. This is a pretty simple example. Okay, let's go back to our original example. So we have this 137 question mark and 21. We have to find this missing number. So what we can do here, let us call that number as a. Okay, now look at the differences. Differences are 2, 4, a minus 7, 21 minus a. Can you find any pattern here? No. Let's go for next difference, which is this 2, a minus 7, 28 minus 2a. Alright, is there any pattern? Yet there is no pattern. Let us go for next number. So we got a minus 13 and 39 minus 3a. Still there is no pattern. Okay, so last number that we are getting here is 52 minus 4a. Now what about this number? So look at here. As we know only four numbers, 1, 3, 7 and 21. So the fourth difference must be 0 in this case. It's like you're finding derivative of fifth derivative of fourth degree polynomial, something like this. That is always 0. So same thing happens here. Okay. Even though there are 5 numbers in the sequence, 1, 3, 7, A which is unknown and 21, but this number A depends on these 4 numbers only, 1, 3, 7 and 21. So there are only 4 numbers which are going to decide the pattern for this sequence. And if there are 4 numbers, the fourth difference should be 0. In this case 52 minus 4a has to be 0. That gives us a is equal to 13. So our missing number is 13. Alright. And the pattern which fits given data is this, x square plus x plus 1. You can check this. Okay, when you put x is equal to 0, start with 0 in this case. When you put x is equal to 0, y will be 1. When you put x is equal to 1, it will be 3. When you put x is equal to 2, it is 7. When you put x is equal to 3, what is this? 9 plus 3, 12 plus 1, 13. When you put x is equal to 4, it is 16 plus 4, 20 plus 1, 21. So this is how we can use this differentiate between consecutive terms to find this missing numbers. Okay, and this is what called as interpolation, as we are finding a number which is between this first number and last number. So this is interpolation. The previous example that we have seen was extrapolation. Alright, so this is how we can use differences to find or predict missing number or next number from the given sequence. Thank you.